Hey guys, this is Coach Brian. I am about to attempt the 7.6 notes as the fastest video I've ever made. And so I'm not going to talk too much. And if you need to pause it or slow it down, go ahead and do that. But 7.6 is our last day in Unit 7, and it is all about the geometric mean. This has a lot of different uses, but in our case, all right, it has a couple geometric uses. And so we're going to focus on those. But first of all, we have to talk about what is the geometric mean, okay? So the geometric mean is we're going to call it an X, but it's a number, and there's an important thing here that it's between two positive numbers. We're going to say those numbers are A and B. So if you have A and you go all the way to B, whatever those two numbers are, it's going to be somewhere here in the middle, okay? It's going to be in the middle of them. And, excuse me, it is, the way you find it, it's the positive square root of their product. And that, remember, means multiply. And so there's a formula for it, and the formula is A over X equals X over B. And so you can see we're kind of setting this up like we've done proportions in the past. And so the important thing to remember is that X, that number is going to be your geometric mean, and your A is going to be your low number, your B is going to be your high number. Or at least your first and your second number, okay? That's a little less important, but it's going to be one of the numbers you're given most of the time. All right, so for example number 1, we're given 2 and 8. So let's go ahead and say that those are A and B. Using our geometric mean formula, we are going to put A over X and set it equal to X over B. And now what we're going to do is we're going to cross multiply here. Okay, so 2 times 8 is 16, and then we're going to cross multiply here, and we get x squared. And now we would just solve algebraically, and so square root squared cancels out, and we have x, and the positive square root of 16 is 4, and that's our answer. 4 is the geometric mean of 2 and 8. I'll do number 3 with you also. I'll leave 2 for you to do, but I'll also do 3 with you because in this one, it's a little bit backward. It says 6 is the geometric mean. So right here where we solve for 4 by using the given numbers, they are giving us the answer, okay, and only one of the numbers. Excuse me. So what we're going to do is, let's just say 9 is our B value. Okay, let's say that's our B value. And so now we're going to set up our formula. We're going to say that A over 6 equals 6 over 9. Okay, I left the A as a letter because it is an unknown variable. And then I put my 6 in as my geometric mean. And now I'm going to do the same thing. I'm going to cross multiply. And so I get 9A. And then I'm going to cross multiply equals 36. 9A equals 36. And again, just going to solve algebraically. Divide both sides by 9. And A equals 4. So A isn't my geometric mean. 6 is my geometric mean. 4 is one of my boundary numbers, my interval numbers, if you want to think about it like that. All right, so we can use the geometric mean to find sides in a triangle. So that's a really useful aspect of it. And what it says here is that we can use the geometric mean, okay, which is the X in our formula. Always a bell every time I'm recording. You can use the X, or you can find the X value because it is the altitude between the two parts of the hypotenuse. So let's clarify that language a little bit, okay? The hypotenuse is the long side of the triangle. You always know the hypotenuse because it's across from the biggest angle, Okay, so that's how we would identify it. And then what we would do is we would draw an altitude line. We covered this a couple of units ago, but if you don't remember, the altitude is when you start at a vertex, okay, at an angle, and you draw a line perpendicular, so at 90 degrees, to the side across from it, okay? So what I've just drawn here in red is the altitude, and essentially what it measures is your height. But we can calculate that, and then we can find the missing sides of this triangle, okay? It's just one method. I know we have learned, about some special triangles and other methods, but what else it says here is that it says when you split the hypotenuse, the parts of the hypotenuse are A and B. So if we look back at our original formula, A over X equals X over B, these two numbers are our A and our B. So what we would do is just plug those in. Let's say A is 18, B is 8, and we would cross multiply, okay, going this way. 18 times 8, okay, 18 times 8 is 144. That should be like ringing a bell right there. You know that's a perfect square. X times X is X squared. And now we find the square root, and our X value is 12. So we know that this side of the triangle is 12, okay? And you know that these angles created by the altitude are 90. And so with this right triangle and two sides, you could then use the Pythagorean theorem to solve for this side and this side, okay, of these two triangles, this one on the right and this one on the left, okay? So that is just one useful aspect of the geometric mean. The second scenario, like I said, I'm trying to move quick here. The second scenario is when we use the X as the leg, okay, one of the medium side of the triangle, if you will. But we use it as the leg, and our A and our B are the entire hypotenuse, and the part of the hypotenuse adjacent to, that means next to, the given leg. So again, let's simplify this language a little bit, okay? If I have a triangle, a right triangle, my leg is going to be the middle length. And then if I were to draw an altitude and make that perpendicular, okay, my extremes are this little part right here and the entire hypotenuse. So this part plus this part, okay, B plus A. So again, that's important. It's the little piece of the hypotenuse, and then it's the whole hypotenuse. So using our formula, this is kind of how we would write it out. We would say that A over X equals X over A plus B, because it's both of these numbers combined. That is the whole hypotenuse. Hopefully I don't run out of room to write this. All right, that's the whole hypotenuse. All right, so using the numbers that we have here, we have created an altitude or drawn an altitude on this triangle, and we got our little 90s, okay? We've got our short adjacent side, and then our whole hypotenuse is gonna be 15 plus 5. So A equals 5, B plus A equals 20. So that's our part of our hypotenuse and our entire hypotenuse. Now, using our formula, we're going to do A over X equals X over B plus A. We're going to multiply these out. Okay, we're going to multiply these out, and we have, oh, wait, I'm so sorry. Made a mistake. Let's rewind real quick. I misread one thing. I'm very sorry. Okay, let's try this again. Our A and our B are the entire hypotenuse, and then the adjacent to the leg. That's what I misread. So if this is our leg, adjacent means next to, it's going to be this number, okay? I'm sorry, it won't be this smaller number. It'll be the number adjacent to. Okay, so what we'll do is that will be, we'll call that our A, and then we'll have B plus A. Okay, so A is 15. The whole hypotenuse is 20. Now we'll set this up. A over X equals X over B, and that will look like 15 over X equals X over 20. And so 15 times 20 is 300. X times X is X squared. We're going to find the square root of both of those. So X equals the square root of 300, which simplifies into 10 square root of 3, or 17.32. Sorry about that misunderstanding. All right, I'm going to work one more with you, and then I'm going to try to wrap this up. Hopefully it's not too long when I hit stop. All right, so the last one we're going to look at here is going to be number 7. So it's to estimate the height of a Douglas fir. That's just a tree, okay? If you're not familiar with that, it's just a tree. James, that's this guy, positions himself so that his line of sight to the top and the bottom of the tree forms a 90-degree angle. So what that means is where his eyes are to the tree forms a 90-degree angle. That's a 90, okay? So if you look, if we turn this triangle, that line right there is our altitude. It's the altitude that we've been writing in. All right, so they form a 90-degree angle. It says his eyes are about 1.6 meters above the ground. So that's this little part right here. That's where the 1.6 comes from. That's from his feet to his eyes. And he's standing 7.8 meters from the tree. So that's the altitude. It's 7.8 meters. It wants to know, what is the height of the tree to the nearest meter? So what we need to do, just to break this down to you, we need to find this side, and then we need to add these two together because we want to know how tall the whole tree is. So in this situation, we have the altitude, which is our geometric mean. Okay, we have our geometric mean. What we don't have is this section right here that we'll call A, okay, one of those extremes. And just to reiterate, the tree, okay, if this is our B and this is our A, the tree is going to be B plus A. So what we need to do is we need to figure out this other extreme right here. So what we're going to do is we're going to use our formula, A over X equals X over B. And we know that our X value, our geometric mean, is going to be 7.8. Okay, we can replace that with 7.8 because that's the number we've already found. And then we also know that our B value, if you look, it is our adjacent side right now, but it is going to be 1.6. And so we would cross multiply, and so we have 7.8 squared equals 1.6 times A. And when we type 7.8 squared into our calculator, we get 60.84. And then we're going to divide both sides. We're going to divide both sides by 1.6. And so our height of A is 38.025, and B is 1.6. So when we add those together, our whole tree should be about 39.625 meters high. Our question says round to the nearest meter, so we're gonna say that it's about 40 meters